In this video, we're going to take a look at finding the inverse of a function. So, we talked about in class with inverse functions that essentially what happens is the output values are mapped back to the input values. Or in other words, in our inverse, the outputs are the original inputs and the inputs are the original outputs. So we kind of boiled it down to simply you switch the x's and the y's is how you find the inverse of a function. But we can do that with a table, we can do that with a graph, but we can also do that with the actual function itself. So that's the main thing I want to take a look at, because that was probably the hardest part of finding an inverse. So when you are asked to find an inverse function on your paper, you literally switch the x and the y in the equation. Their positions, you don't change anything else about the equation, just the x and the y. Then you use techniques that we've used in the past to solve this equation for y. So what we would do is we would add this 4 to this side and to this side. You would end up with negative 1/3 y. This would cancel, and over here x plus 4 is x plus 4. Remember, you can't really add those together. Then we want to get rid of the negative 1/3 y. Now technically you could divide by negative 1/3, but that would cause a pretty ugly division on the left hand side of the equation. So what I suggested in class is that when you're trying to get rid of a fraction like this, is to multiply by the reciprocal, which would be negative 3 over 1. And the only reason I put negative 3 there is because negative 3 over 1 is really just negative 3. But notice I just do the same thing on both sides. I distribute a negative 3 on the left hand side, just like I multiply the negative 3 on the right hand side, because distributing is multiplying. So we end up, the negative 3 times the negative 1/3 cancels out to positive 1y on the right hand side. On the left hand side, we distribute the negative 3 times x. You get negative 3x. And then negative 3 times 4 is negative 12. So this function here is the inverse of the original function up here. Remember, we also talked about you could check and see if they're inverses of each other by plugging them into each other. Meaning, if you took the negative 3x minus 12 and plugged it into here, what you would end up with is everything except x would cancel out. So, let's take a look at one that is not a linear function, and that has this little f of x thing that some of us are scared of. This, remember, is just another way to write y. We use it because sometimes we're dealing with multiple functions. To find the inverse, you do the same thing that we did before. You switch the x and the y. And then you solve this equation for y. So the first thing we would do is add 2 to both sides. X plus 2 equals y to the 2/3 power is what we would end up with. Now, after that, we want to get the y completely by itself. So one of the things that we talked about is when you have this y to the 2/3 power, that really means the cube root of y squared. But that would mean I would have to get rid of a cube root and get rid of y squared, so that would be 2 steps. But I gave you a shortcut. If you have this 2/3 power and you want to get rid of it, you can raise it to the 3/2 power. And what you do to one side, you got to do to the other. So you raise the other side to the 3/2 power. As long as you raise both sides to a power, that's okay. You're keeping the equation equal. But you are also getting rid of this 2/3 because 2 times 3 would be 6 and 3 times 2 would be 6. That's 6 over 6, or just y to the first power. We've got y by itself. Now this x plus 2 to the 3/2 power, yes, you technically could rewrite it as the square root of x plus 2 cubed, but you don't have to do that. You could leave it as x plus 2 to the 3/2 power, and that would be okay as well. Also, we talked about this notation as well. Instead of writing y equals, writing it as the f inverse function, because this is the inverse of this function. The same thing would happen to this if we plug this function into this one. It would cancel out to just x. That is what inverses do to each other, whether they're linear or not linear. It doesn't matter. Let's do one more quick one, finding the inverse of this function. Now I'm going to go through this, like I said, relatively quickly, but it'll give you another one. You could try it, pause the video, and then see if you got your answer right. So you switch the x and y. Subtract 6 from both sides. Divide by 8. And then take the cube root of both sides. Now that's one of the reasons here that I left this as a big fraction over here. Because what is the cube root of 8 on the bottom? The cube root of 8 on the bottom is 2. So this would be the f inverse is the cube root of x minus 6 over 2. And I didn't have to do anything weird with that denominator, like rationalize the denominator. So to find an inverse, you switch the x and y, and then you solve for y. Switch the x and y, solve for y. Switch the x and y, solve for y.